Today we're going to look at some of the major vocab terms that are going to come up in our Unit 4 about angle pairs. So our objectives today are to identify corresponding angle pairs and to identify parallel, perpendicular, and skew lines. So the first thing we're going to do are to identify these sets of lines. So we have this rectangular prism over to the left, and with that we're going to name all of the pairs of parallel, perpendicular, and skew lines that we can find. So for parallel lines, those are lines that are, they have like the same slope if we're looking in a coordinate plane. So they are going to be in the same plane and they're never going to cross. So if we're looking at parallel lines, we're going to find all the sets and we're going to name them by their endpoints. So if we start up here with CD, so let's start with CD. And if we want to name all of the lines that are parallel to CD, then we'll have CD is parallel to GH would be parallel. It's in this front plane of this rectangular prism. So CD is parallel to GH. CD is parallel to AB. So that would be on the plane that's the top of this rectangular prism. Then we have a plane that isn't represented by a side, but they are still parallel. So CD will also be parallel to, if we think about a plane that goes through the middle of this rectangular prism, it would also be parallel to EF. So those are going to be all the lines that are parallel to CD. Now we can come up with different arrangements of these that we haven't looked at before. So now if we think about the segment AB, since we've already looked at all of these, we've already said that AB is parallel to CD, but we can also say that AB is parallel to EF, and AB coming across the diagonal of this plane is GH. So if we move this down to EF, the last thing that we haven't stated yet is that EF is parallel to GH. So those are all of the horizontal lines in this figure. We can then also look at all of the vertical lines of this figure. So we can start here with AE. And we can make the same kind of list. So AE is parallel to BF. AE is parallel to CG. AE is parallel to DH. So that's one where we have to think about that diagonal through the figure. So then we can move our focus. We can start with BF and come up with the other relationships for BF. So BF is going to be parallel to DH. It will be parallel to CG. Then we can go to another one, like if we say CG, then CG will be parallel to DH. That's our list. So we have a total of 12 sets of parallel segments here. All right, so the next thing we're going to look at is perpendicular. So now if we think about perpendicular, those are going to be our corners. So with the red and the blue here, I have a perpendicular set. And I'm going to have to go through sets like that. So starting with this one, we have that AB is perpendicular to AE. So they're going to have to share an endpoint, and that's going to be where they cross. So it's going to be any horizontal and vertical set that cross there. We can also have So now AB can also be perpendicular to AC, which I just realized we didn't do the parallel sets for AC. So you can also do AC, BD, FH, and EG. We need to add those up here. So then, those are all of the perpendicular parts that come from point A. Then we can move to a point B. So, like AB is perpendicular to BD, and AB is perpendicular to BF. So at any intersection here, any corner of this figure, you're going to have 2. So in total, since there are 8 total corners of this shape, we should have 16 total perpendicular relationships. And so I'm just going to leave it with these 4. There should be 16. So I got up to 12. I should actually have 18 parallel sets. So now let's go through AC. So that's the one that I hadn't gotten to. AC would be parallel to EG. It would also be parallel to FH and BD. So then we just choose another one, like BD is parallel to FH, and BD is parallel to EG. Then we just take another one that we haven't started with, like EG, and we finish it out with FH. So here are all 18 of those parallel sets. We'll have 16 perpendicular sets. So that's going to be 2 for each corner. So we've done A, we've done B as a corner. Now let's go to C. So for C, we could have AC is, take this down a little bit, perpendicular to, it could be CG. AC is perpendicular to CD. So those are with the corner C. Now let's do D. So CD is perpendicular to BD, and CD is perpendicular to DH. Moving on to E. So AE is perpendicular to EG. AE is perpendicular to EF. Right, our next letter is F. So BF is perpendicular to EF, and BF is perpendicular to FH. Next one's going to be G. So like EG is perpendicular to CG, and EG is perpendicular to GH. Now let's do H. So DH perpendicular to GH, and DH is perpendicular to FH. So, doing this, I realized that there are actually going to be more than 16 on this one. So, since we had AE is perpendicular to EG, and AE is perpendicular to EF, EF and EG are going to be perpendicular. So we have to add in that extra one. So 8 corners, and there will be 3 perpendicular statements for each one. So this is actually 24. So I'm not going to finish those off, but there are the first 16. All right, so the last thing we need to go over are skew lines, and skew lines are lines that never cross, but they're not in the same plane. So what we mean by not in the same plane let's look at AB here. So if they don't cross, but they can share a plane, then those are parallel. But we have some sets that don't cross but aren't in the same plane. So like if we look at CG here and AB back here, see how this line will go on and on forever horizontally in the background over here. But CG is in the foreground, so it's going to go on and on vertically, but since they're not in the same plane, those two lines will never cross. So those are going to be sets like these two. So AB and CG will be skew lines. So if we want another line that would be skew to AB, AB is also going to be skew to DH. Those are never going to cross, but they're not in the same plane. So another set would be AB and EG. So those are not in the same plane either. So then along with that, AB and FH would be skew. So I'll let you finish off this list as well. So we have a complete list of all of our parallel lines. We have 8 more perpendicular sets that we need to find. And then I'm not going to tell you how many, but I want you to find the rest of the skew lines. So skew lines not in the same plane. Parallel and perpendicular, those have to be in the same plane. So the next thing we're going to look at is a couple postulates. We have the parallel postulate, which says that for a point that is not on a line, there is exactly one line that's parallel through it to the given line. For the perpendicular postulate, if we have a line and a point that's not on the line, then there's exactly one perpendicular line through that given point. So the next thing we're going to look at is a construction. So it's drawn out here, and then I'm going to go over what this means. So what's given here is that we have a line, which is right here, and then we have a point that's not on the line. So point P is not on the line. So from this, we're going to do this construction, all these little arcs. I'm going to show you where those come from. So what we're going to do is we're going to mark points on the given line that are equidistant from the external point by drawing part of a circle centered at the external point and crossing the given line. So that's this arc right here. So what that means is that if we use a compass, we are going to center it at the external point, which is here. And we want to make sure that it's going to cross that line, but it doesn't have to be any certain distance. So this one, it was set at this distance, and we just want to make an arc. So based on this, we're going to make any arc. This picture is stretched a little bit. That's why that arc didn't exactly match up with the one that was given there. So this is going to be mark points on the line that are equidistant from the external point. So remember that a circle has a given radius. So on this one, this is my radius. So if I am looking at this point is a radius away from P, as well as this point. So those are equidistant points. So those are the points that we're talking about whenever we're talking about equidistant. So this point right here is equidistant from P as this point is. So these distances would be the same. So those are the equidistant points. Step 2, set the compass at any length that is more than the distance to the point, more than the distance from the point to the line. So if I have my compass, I'm going to change the color for this one. So set the compass at any length that is more than the distance from the point to the line. So I want to set it at any length that is more than the distance from the point to the line. So this is more. Let's use that one. Then I'm going to set the compass at one intersection of the arc and the line. So one intersection just means one of these points where we said it was equidistant. So I'm going to set my compass here. And I want to make an arc that crosses above and below the line. So I've got my distance. I'm setting it here. Now, I'm just going to take this. I want it to meet below and above. So I'm going to have to make a big old arc. So here we go, above the line, below the line. I'm going to do the same thing from the other point. So if I'm here, I want to be below the line and above the line. So I'm going to erase the parts that I'm not talking about. So I can't pick up my compass and just do it in one place like you usually can if you're using a compass, just because I'm on a computer. So that's where these X's come from. So you can see the X above and below. I'm only focusing on those intersections. So this part right here that I had to draw is not really necessary. So I just wanted a mark above the line and below the line. So now if I draw a line through those intersections to the new arcs, that's going to give me the perpendicular line. So I want to draw from this intersection to that intersection. So it hits that point and it goes through the line. So we can check this by using a protractor. So if we line that up, notice that it is exactly 90 degrees. So that's the construction for making a perpendicular line through a point. So we didn't use this protractor to set it up or anything. That's how you can do it without having this measurement. And that'll work every time. So we'll focus on constructions later on. All right, so next we're going to look at these angle pairs. So these are just our terminology. So alternate interior angles are on opposite sides inside the lines. So the lines I'm talking about are M and N. So opposite sides mean like left or right inside the lines. So alternate interior angles, we're going to list those next. Alternate exterior is on opposite sides outside the lines. Linear pairs are angles that share a ray and form a line. So remember, it's opposite rays and then they share a ray. So we'll look at linear pairs. Corresponding angles are in the same spot on different lines. And remember, whenever we're talking about lines, we're talking about M and N. Consecutive interior are on the same side inside the lines. And vertical angles are angles across from each other at an intersection. So they're not adjacent. They don't share a ray. They're made up of two sets of opposite rays. So now let's go on down and start naming these angle pairs. So from this, if I want to know my sets of alternate interior angles, so remember alternate opposite sides, interior inside lines M and N. So alternate interior, that's going to be angle 3 and angle 6. So opposite sides inside. The other set is going to be angle 4 and angle 5. Alternate exterior, those are points that are angles that are outside of the lines on opposite sides. So if I would start with angle 1, its alternate interior angle will be angle 8. And for angle 2, the alternate exterior angle will be angle 7. Those are our only two sets there. All right, so for linear pairs, those are going to be any two angles that share a ray and form a line. So we're going to have a lot of these pairs. I'm going to do a few for you, and then I'm going to leave the rest for you to make up the list. So linear pair would be like angle 1 and angle 2. They share a ray, and they fall in a line. So angle 1 and angle 2 are a linear pair. Angle 2 and angle 4 are a linear pair. They share this ray. Angle 3 and angle 4. And then angle 1 and angle 3. So I want you to make up the list for this other set. So I'm going to do the same thing for corresponding angles. So corresponding angles are on the same spot on different lines. So if I look at angle 1, that's in like the top left. The corresponding angle to angle 1, top left over here, is angle 5. So angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. So I want you to find the corresponding angles for 3 and 4. All right, I'm going to come up with one of the consecutive interior angles for you, and you have to find the other set. So consecutive interior means same side inside the lines. So the one I'm going to give you is angle 3 and angle 5. So angle 3 and angle 5 are in the same spot, are on the same side inside the lines. There's one more set for those. All right, in vertical angles, like linear pair, there's going to be a lot of those. So I'm going to give you one set, and I want you to come up with the rest. So the one I'm going to give you for vertical is going to be angle 1 and angle 4. So they have to be across from each other at an intersection. So formed by two sets of opposite rays. So angle 1 and angle 4 are vertical angles. There are 3 more sets of those. So go on and finish off those lists, and then there's an exit slip and a homework for you.